Hey everyone, it's Stats. Today we're going to take a look at our next set of probability problems, and this is going to be lesson 5.2 day 2, 5.1 day 2, and this is our soda contest reel, and we're going to look more at this idea of probability and what this means in the long term. So let's just go have a look over here. And Pepsi ran a promo contest for their 20-ounce bottles of soda. Some caps said, "Please try again," and other caps said, "You are a winner." Pepsi advertised the promotion with the slogan, "1 in 6 wins a prize." So Mr. Ferraria's stats class wonders if the company's claim is true. Pepsi, of course. To find out, all 30 of the students in class go to the store and each buys one 20-ounce bottle of soda. 2 of the 30 students got a cap that said, "You're a winner." So how many winners did we actually expect in this class of 30? Well, in a class of 30, 1/6 of them were supposed to win. So 1 out of every 6 of the 30 is equal to 5. So we expected 5 winners. Winners expected. And of course, this is not guaranteed. Okay, well, we didn't get 5. We only got 2. So does this result give us convincing evidence that 1 in 6 claim is inaccurate? We're going to perform a simulation like we did in the last chapter to help us answer that question. We're going to assume, so always have to start with an assumption. We're going to start by assuming that Pepsi is telling the truth. So if they're telling the truth, what's the probability of getting 2 or fewer winners in class purely by chance? So let's find this out. So question next is, what can we use to model a 1 in 6 probability? And 1 out of 6, that sounds a lot like dice, doesn't it? Well, actually, we're going to use a spreadsheet. Because times of COVID, right? If we were in class, we probably would be rolling dice. I have a class set of dice that we could use. But this being what it is, we're not going to roll any dice. We're just going to go ahead and use our spreadsheet. And we're going to assign outcomes as winners and losers, and we're going to list them below. If we were using dice, we would say, actually on the spreadsheet too, 1 is going to be a winner. And then 2 through 6 is going to be a loser. So we're going to roll our die 30 times to imitate a process of the students winning, to imitate the process of the students in Ferraria's class buying their soda. How many of them won? Okay, so here we have my spreadsheet, and you will see over here, we're going to do a random number between 1 and 6. If that number is a 1, we're going to count it, and that'll tell us how many wins. So that shouldn't be percentage of wins. This should just tell us the number of wins. This is going to count how many 1s we have in the list. So I'm going to copy this down to the next one, and we got a 4 and a 1, so that's 1 win. And every time I copy it, it's going to give me a new set of numbers. So here are 30, and I got 3 winners. Okay, so in my first trial, I got 3 winners. So how many of them won a trial? 3. Repeat the process again. Okay, I'll repeat the process again. Let's copy this down. And now we got 2 winners. Woo! Pepsi's being stingy. So we got 3 and 2. You could probably go over here and count. Look for all the 1s. There's a 1 there. There's a 1 there. There are no other 1s. So indeed, this spreadsheet worked, It gave me random numbers between 1 and 6 and counted only 2 of them were winners. So we're going to put them on a dot plot, and we're going to do this many times to do this for the whole class. Well, I don't have the whole class with me, so I'm going to just do them all over here. So I've already done 24 of them. The last 2 were 3 and 2, so I'll add them to my list. 3 wins and 2 wins. And then I'm going to take a look over here, and I'm going to see every time I do something on this spreadsheet, it's going to do the simulation all over again. So let's see. Let's see if we can get one. Oh, there we go. 4 and 8 winners. Whoa, that was lucky. 9 winners. And for this last one, 5 winners. So that got us this nice dot plot over here. I had my spreadsheet make a dot plot for us too. So here are the number of winners, and we did 30 repetitions. So there should be 30 dots here, and I'm going to copy and paste this over. Copy and paste it over, and you know what I'm looking at is it looks like we're supposed to do 2 dots per person. So actually I should do 60 dots. So I'm going to get rid of this. I'm going to go to 60, and let's just extend this out to 60. Ooh, that's a lot of trials. And oh, wait, no, I did the wrong one. Hold on one second. 60 trials over here. So I'm just going to keep on going with this, and we'll see what we get. Let's do the next one. That's 5. Next one's 4. Next one's 4. Next one's 5. And I'll see you in a couple of seconds. Just about finished here. 6 winners. 6 winners again. 7 winners. And last one, 6 winners. So let's take a look at the way this dot plot looks now. So this should be... Oh, you know what? I forgot to extend this out also. So let's extend out this. This gives me my cumulative number of wins. There we go. And there's our dot plot. Okay, I'm going to make a couple adjustments here. So there we go. We just kind of adjusted it so that we could see the top of this graph. And we're going to go back over here, and we're going to copy and paste the dot plot over here. And I think it's important for us to remember what each one of those dots stands for. So each one of those dots represents the number of winners in a single trial of 30 bottles. So each dot that you see here is 30 bottles. How many winners in those 30 bottles? So what percentage of the time in Mr. Ferreria's class did we get 2 or fewer prizes just by chance? So we can count this. How many are 2 or less? 1, 2, 3, 4, 5. That looks like 6 to me. So 6 out of 60. 6 out of 60, which equals 0.1, which is 10%. So 10% of the time, a sample of 30 got 2 or fewer winners. So does it seem plausible now that the company is telling the truth, or did the class get unlucky? In other words, do we have convincing evidence? And I'm going to go ahead over here and I'm going to say that this is statistically significant findings. So you might be thinking 10%, well, that's pretty low actually, but it's not extremely low. 10%, is not at a level where we would say we have statistically significant findings. Remember from last chapter, we had said that statistically significant means 5% or less. So, since more than 5% of the trials resulted in 2 or fewer wins, which is what we got from our first experiment, we don't have convincing evidence that Pepsi is lying. Now, that might hurt because 10% does feel really low, but this is what we came up with. It is possible, if Pepsi is telling the truth, it is possible that only 2 or fewer wins would occur in a class of 30, and it happens 10% of the time. So it's not particularly rare. Which brings us to these important ideas about simulation. So here are some important ideas. First of all, what is a simulation? And a simulation is an imitation of a chance behavior based on a model that accurately reflects the probabilities of the situation, or at least it accurately reflects the presumed probabilities of the situation. Examples that you can use are dice, coin flips, and random number generators. Remember, random number generator is something that you can either find on a spreadsheet or your calculator. The process is as follows. First of all, describe how the chance device is going to imitate the situation. After that, you're going to record the results of many trials, and then you're going to use an accumulation of those results. Like, we did the trials 60 times just now, and we use the accumulation of all those 60 trials to answer a question, usually by finding the probability. So if we get our probability that we found was 5% or less, then we say that we have statistically significant results, which means the model that we use does not reflect the actual probability. So if we had gotten, we'll go back up to the Pepsi, if this was 2%, then we would say, okay, well then, if we only got 2 or fewer prizes 2% of the time, then the model is probably wrong. And the model was 1 out of 6. So probably 1 out of 6 is not correct. Less than 5% is that statistically significant idea. So in Check Your Understanding, we're looking at a basketball announcer suggesting that a certain player is a streaky shooter. That is, the announcer believes that if the player makes a shot, the player is more likely to make the next shot. And as evidence, the announcer points to a recent game where the player took 30 shots and had a streak of 10 made shots in a row. So is this convincing evidence that the streaky shooting is this convincing evidence of streaky shooting by the player? Assume this player makes 50% of the shots and that results of a shot don't depend on the previous shot. So let's describe how we would carry out an estimation of 50%, or how we would carry out a simulation to estimate the probability that a 50% shooter who takes 30 shots in a game would have a streak of 10 or more. So first of all, let's see what we were supposed to do. We're supposed to describe how the chance device is going to imitate. So what chance device are we going to use? What gives us a 50%? Clearly a random number generator will do it, 1 and 2. But if you don't have a random number generator, then 50% is easily done with dice. Or not dice, dice too, of course, but a coin. Flip a coin. Heads equals a made shot, and tails equals a miss shot. Missed shoe. That's funny. I should have left that. Okay, next we're going to record the results of many trials. So you're going to flip the coin. How many times? 30 times. and record how many times the player has a streak of 10 or more. Okay? And then, yeah, so that's going to be one result. One result would be 30 trials. So then we're going to do that many times and repeat the process many times. Okay. And then count how many streaks the player has. Right, so here is the dot plot shows 50 simulated games in which the player took 30 shots. And the longest streak in that simulated game. So the longest streak, so this is a little bit of a different process than what we did. The longest streak here. Explain what the 2 dots above the 9 stands for. This means that in 2 games, the longest streak was 9 made shots. Okay. And finally, what conclusion would you draw about whether this player is streaky? And to answer that question, we ask ourselves, how many times do we get a streak of 10 or more? And that was just 1 time. Okay. Basically, we're looking at all of this area to the right and including 10. Okay. And so what we're saying is, let's pretend that he wasn't streaky. Let's pretend that he just made 50% of the shots no matter what. And if he made 50% of the shots no matter what, then there is only a 1 in 50 chance of having a streak of 10 or more, which is less than that 5% level that we were talking about earlier. So since that streak of 10 shots or more is unlikely, we've got to conclude that our hypothesis is incorrect. In other words, the player's percentage is not really 50%. So the conclusion is the player is streaky. He's not really a 50% shooter. He's a streaky shooter since he had that streak of 10 shots or more. Well, that's our first look over here at simulation and, well, not our first, I guess our second look at simulation, and our look at, well, really statistical significance. Hopefully that all kind of made sense to you. Remember that the number is 5%, and if your results only occur in the simulation less than 5% of the time, then the probability model that you based your simulation on is probably wrong. Okay, so that's it, and have a good time, and we'll see you next time here on Statistics.